Hello, everybody. So today on Puzzle Time with MoMath and MathPickle, we are going to be looking at lichen. And I'm going to ask you guys to all turn on your cameras if you can, just because it makes a better community. And
I
yes.
can't.
Oh, okay. Avocado cream. If you can't, that's okay. Just if you can, turn on your cameras, and then we can all be part of this together. Here is a little video I made a while ago on this this puzzle that like looking at me on this, I was pretty young, so this must have been like 8 years ago or 10 years ago. So here we go. I'm going to share 2 minutes of this video just to introduce the puzzle, and then we are going to do it ourselves. So here goes.
Hello, Tweedledum and Tweedledee. What are you two doing today? Walking the wilderness. And what are you looking for? Lichen. That's an odd thing to be doing. Why are you doing that? Yes, they are. I guess it's a fungus together with algae that creates that symbiotic relationship. Do you guys want to see a mathematical symbiotic relationship? We can create sets that are symbiotic. Do you want to try naming one? Try naming one. Okay, 1, 2, 3, and 6. So let's take those. We're only going to use multiplication and subtraction in this case. And we're going to see if we can create each one of those numbers using other numbers in the set. So for example, 1 you can create only multiplication and subtraction. 1 you can create with 3 minus 2. 2 you can create with 3 minus 1. 3 you can create with 6 minus 3. And 6 you can create with 2 times 3. Is this a symbiotic set? No, it is not, because the 3 is not created with other numbers in the set. It's created by itself. You need the 3 in there to describe, to create the 3. So this is not a symbiotic set. So try again. 1, 2, 7, 8, 10. Okay, so 1 you can create with 8 minus 7. 2 you can create with 10 minus 8. 7 you can create with 8 minus 1. 8 you can create with 10 minus 2, and 10, no, there's no way to create it. So this has totally failed. Try again, guys, try again. Okay, let's see. So 1, 2, 4, 7, 8, 12, 14. So 1 you can create with 8 minus 7. Now you can only create these in one way. So like if you have multiple ways to create them, you also have a problem. So 1 you can create with 8 minus 7. 2 you can create with 14 minus 12. 4 you can create, how are you going to create 4? 12 minus 8. 7, 8 minus 1. 8, 2 times 4. 12, 14 minus 2. And 14 is 2 times 7. Are we successful here? Sadly not, because you see, look at the number 8 there. 2 times 4, but we can also make it 12 minus 4. In this puzzle, you can only do it, every one that you want to make, you can only make it in exactly one way. So you failed again, you guys. No, don't fight, don't fight. Look, guys, no, this is, okay, these are hard, but let me give you an example of one that does work. So I'm giving you the 1 and I'm giving you the 12. And you guys have to figure out the 3 unknown digits to make this a symbiotic set. Try it.
Okay, so that's where we are stopping the video, and you guys, including me, because I've forgotten the solution here, we have to somehow make this a symbiotic set. And again, anyone who can turn on their video, turn on your video. It makes it a better, warmer community. So please, if you can, do it, and no problem if you can. Okay. Amelia, do you have, I think it's probably too hard to solve all of these together. So I don't know, do you have any ideas about how you might tackle this? You can only use subtraction and multiplication to solve this.
supposed to figure out like what numbers?
Yeah, there's 3 numbers in there between 1 and 12 that will make this symbiotic set, a set that every number in the set can be created using multiplication or subtraction from other numbers in the set. So that's the idea. Not, it's just, I don't want you to give some numbers because that's too hard, but do you have any ideas about how you would go about solving this?
Well, we could see if there's like a pattern of like numbers distance 4 apart tend to have a good chance of working or something.
Okay. Steph, you've got an idea.
You'll need 2 consecutive numbers, and those 2 consecutive numbers cannot be 1 and 2 because.
Okay. So Seth, your sound is really bad, but I heard that you're suggesting 2 consecutive numbers because somehow we need to make that 1. And so that's what he's looking for. So 2 consecutive numbers. Good. Okay. Sorry, I have to turn off my cell phone here because someone keeps on calling me. And there we go. Power off. Yeah. Solly, do you have any ideas?
So I feel like we should do 12 minus 1, which will give us 11.
Okay.
And since it's a prime number, there's no other way to get it.
I
Okay.
have a good idea.
Okay. So, Oscar, would you like to annotate?
No, I'll just tell you. It's 3
Okay, that's
and
fine.
4. 4 minus 3 is 1, and 4 times 3 is 12.
Okay, so I'm just going to go in here. So we're going to go for 3 and 4
And 11?
and 11.
You could go
Okay.
3, 4, and 7, and it would all work out, right?
But no, this doesn't work. This doesn't work. This doesn't work.
If you do 3, 4, and 7, then the 7 can take care of both the 3
Okay.
and the 4. Well,
This doesn't work.
So on Seth's really bad sound system here, I am
7,
hearing him
yeah,
saying
7.
7. So let's see if that works. So,
11 doesn't work because 12 minus 11 is 1, and 4 minus 3 is 1.
okay, yeah, there's 2 different ways to make the 1. Yeah. Ruta, are you happy with the number 3? Is there exactly one way to make the number 3 using subtraction or multiplication?
Yes.
How do you make it?
4 minus 1.
4 minus 1. Right. My goodness, I wonder if I've made a mistake in this puzzle.
You can
Because-
do 4 minus 1 or 7 minus 4.
So there's 2 different ways. So I hope I haven't made a
Makes it
mistake.
wrong.
Like I could have made a mistake in this puzzle because yeah. So that's not good at all. That's 2 ways to make it. Oh no.
Uh-oh.
Yeah, maybe this is not good at all.
Oh no.
Yeah. So this is a fail. So perhaps this is an impossible puzzle that I by mistake missed that I can make 3 in 2 different ways.
Oh no.
Avocado cream, do you want to try something else? Or do you want to just say, I've made a mistake? Have you ever known me to make a mistake before, avocado cream?
Not really.
I do. Yeah, lots of times. So any other ideas we have to solve this? So you can also talk about general strategy. For example, the number 12 here. How are you going to make the number 12?
I feel like if somehow we could get to work with a 2 in there, we could and we somehow also put in, we could also use, we could, well, I mean, you could maybe somehow put in a 2 and a 6, and that would probably not work, but just pretend it would.
Those seem like two good ideas. 3 times 4 is 12 and 2 times 6 is 12. So, excuse me, it seems like those might be two good ideas. Stick person, do you want to try to solve this? Are you there, stick person? You're muted right now.
I think 11 would work here.
11, okay. So how are you going to make the 12? Oh, with 2 times 6. How are you going to make the 11? 12 minus 1.
11, oh, we're not doing addition. Oh, that's right.
No, we're not doing addition. But it looks good so far. 11 is equal to 12 minus 1. 6 is equal to, oh. Yeah, so it doesn't work with addition.
Is this
I don't know if this is possible. Maybe I did make a mistake. Nathan, go ahead.
Okay, so what I was going to suggest is that maybe try 1, 3, 4, 8, and 12.
1, 3,
so just like the first one that we tried, except with an 8 instead of a 7.
Okay.
So what we can do is that 1 is 4 minus 3, and just 4 minus 3.
Yep.
And 3 is 4 minus 1, and just minus 1. 4 can be as 12 minus 8.
Yes.
Oh wait, except 4 can also. Oh wait, that's because I thought. Okay, hold up. So we can just have 12 minus 8 because we don't have addition, right? Okay.
Yeah, you don't have addition.
So it's just 12 minus 8.
Yeah, that's 4.
And then 8 is just 12 minus 4.
Yes.
And then 12 would be a 4 plus 8. Oh.
Okay.
You can't do addition. Uh-oh.
Oh, right. So it can't be 4 plus 8. So it doesn't work.
But you can do 3 times 4.
Oh yeah, of course, 3 times 4. 3 times 4 does work.
Found it.
Yeah. Okay, so this does work. This is a success. Okay.
Woohoo.
Yeah. Good. Okay. So now it's time for us to do that. Let's shrink
time for
this.
poll?
Oh, thank you. Oh my goodness me, you guys are great.
Yep. I told you don't need to set yourself an alarm.
Yeah. For all of you here, please remind me if I don't remember to do a poll at about 15 minutes, you can say, Gord, we need to have a poll. So that's great. Thank you.
A couple days ago, maybe a week ago, we didn't have one.
I know.
Uh-oh. I'm fine.
Okay. So sharing my screen again, this time. Okay. So welcome to Puzzle Time with MoMath and MathPickle. And here is the Lichen Puzzles. Here is your first question. After the first question of the slideshow, you guys are again going to be able to go into this slideshow in about 10 minutes, and you're going to be able to do your own puzzles. But for now, we're going to do them together. And go ahead. Let's see. Who would like to? Amelia, do you want to? Well, why don't we all just take a guess? Thumbs up. Maybe we'll take a 17 seconds, and then we're going to give a thumbs up. This is a symbiotic set, or a thumbs down. This is not a symbiotic set. So 17 seconds to just look and get a feel and figure out what you
Definitely
think.
not.
Probably not.
That wasn't 17 seconds. I should have said 17 seconds of silence. But okay, this one, we'll say that this one.
There's more than one way to make 60.
There's more than one way to make 60?
Yeah, 12
And-
times 5 and 20 times 3.
And I'm not sure
Right.
about 7.
So it doesn't work. Yeah.
Yep.
Yeah, so that doesn't work. And is there a problem with 7?
3 has 2 ways to be expressed.
3 is equal to 7 minus
3 is
4.
equal to 60 over 20 also.
But we're not doing division, Oscar. Okay, so that is another puzzle for you guys to design. A puzzle where the operations are only division and addition. But for all of today, you can ignore division. You can ignore addition. The only 2 operations are multiplication and subtraction. Okay. Next bit of lichen. Here we
Gordon?
go.
Gordon,
Yes.
Just Taco Cat had their hand raised, and also Nathan did briefly. Just wanted to, if you didn't.
Okay. Yeah, go ahead, Taco Cat.
I do not.
Taco Cat? I can see you sipping your orange juice there, but you're muted. Oh,
Ooh.
okay. I love the symbolism. No, okay. Nathan, you've got a question or
So
comment?
what I want to say is that going back to the first lichen puzzle,
Yeah.
I also noticed that I can't seem to find a way to get 4.
Oh, you're right.
You just do 7 minus
7
3.
minus 3.
Oh, 7 minus 3.
Yeah.
Okay, never mind.
Right.
Again, that first one isn't a symbiotic set because 60 can be 5 times 12 or 3
Yeah.
times 20. So
Right.
just say
Okay. And now, Nathan, I'm keeping you on here. I'm keeping you on. Don't think you can scoot away. Tell me about this one. Or do you want 17 seconds silence, Nathan?
you know what? I'm fine just like this, okay?
You're happy with this? Okay, you go ahead, solve it. Okay, Taco Cat, you've got an idea for this one. Go ahead, Taco Cat. Taco Cat, you are a very silent little cat today.
Gordon, maybe if
something's
you, they might be having an issue with their mute button. Maybe you can roll over them on the participants list and ask to unmute. That might help.
Okay.
Okay, so I'm just going to say I can't find any way to get 25 by just multiplication or subtraction.
Yeah, me too. That's what I was thinking.
You can't get 10 either, can you?
I know
10?
a way to get 26.
Actually, wait.
Not
10 is
25
25
minus
minus
15 is 10.
Oh, sorry. Wait.
But I can't find anything to get 25.
I don't think there's a way to get 25.
There is no way to get 25
This
because
is not a symbiotic set.
the only option would be to have actually, wait, no, there is no way to get 25. Absolutely no way unless you had bigger numbers.
Unless
Or
you're
one.
doing, even if you are doing addition.
So I have checked people's microphones, and it seems like everyone can unmute, can mute and unmute. If someone can give me a thumbs up that that's accurate. We just have a question mark about why Taco Cat's fretting there, but if you can just give me a thumbs up that you can mute and unmute. Yes, we've got a one yes,
I'm here.
2 yeses. Yeah. So
One no.
I'm not sure what's wrong, Taco Cat, but you are in our thoughts, and we know that you're not silent on the other side of that screen.
Yeah.
Yeah.
If you have the link, it might be worthwhile to try to rejoin the meeting from scratch.
Oh, true.
That might work.
Yep, there he
Good
goes.
suggestion. Yeah. Thanks, Katie.
So continuing on with the symbiotic set, this set is not symbiotic because 25 can't be made with just 2, 10, 13, 15, or 26.
Okay.
Using multiplication or subtraction.
Right.
25 equals question mark.
Right. We don't know how. Angie, your turn. Here is another little bit of lichen.
Yep.
And Angie, you can ask if you want 17 seconds silence. I'll give you 17 seconds silence. Do you want that?
I kind of missed the instructions.
Oh, okay, okay. So in this puzzle, each of these numbers has to be created by 2 other numbers in the set using multiplication or subtraction. So for example, 3 is okay because
I
No,
don't.
this is not a symbiotic set.
There's a
I
problem with 15. With 15, you could do 3 times 5, but you can also do a 21
There's
minus
also
6.
a problem with the 3.
oh
8
no,
minus
no,
5, 15 divided by 5. Oh wait,
don't-
there's no division.
there's no division, Oscar. Yeah, so 8 minus 5
There's
is
a
equal to
problem
3.
with 15.
But 15 is,
How many no's?
That's
in
a
the
21
alphabet
minus
give
6
us
and 3 times
one?
5.
there's 2 ways to get to the 15.
So wait,
So Angie, you see the way it works? This is
Yes.
not a symbiotic set. There has to be exactly one way to make every single number using other numbers in the set. So 15 is the failure here because 21 minus 6 and 3 times 5 both make 15. Okay, so that's a fail. Right.
I'm wondering that if you have 2 options,
Yeah.
but one of them has the number you're trying to get in it, so say one of them had the number 15 in it, would it still be valid?
Yeah, that's
Considering-
valid then. You have to use different elements of the set to make your equation. Yeah. Yeah. Okay. Here we go. 17 seconds silence this time, everybody. So nobody say anything, and we will try to figure this out. And then we'll do a thumbs up or thumbs down after 17 seconds of quiet, starting now.
It's invalid. It doesn't work. It's not symbiotic. Because with 24 you could do 4 times 6, but with you can also do 60 minus 6 for 24. So yeah, 24 doesn't work.
Wow, these have all been no's.
All no's. That's
And you also can't get 6.
Yeah.
6. Oh yeah, that
Can't
also
really get
fails.
6.
20 minus 14.
Can't really get 6.
Oh, 20 minus 14.
20 minus 14.
I'm making a lot of
Yeah, but the 24 is still invalid, so it's invalid. Yeah.
Yep. Even one tiny detail will mess up the entire thing.
So I actually noticed that. Are you talking about 20 or 24 being invalid?
24. We're talking about 24.
Okay, well, if you look at it, 60, let's see. Well, if you look at it, so what did you say it wasn't valid about 24?
60 minus 6 and 4 times 6. Oh,
So
wait. Oh, no, it doesn't work. Sorry. 60 minus. Oh, wait. Oh, dang it. I thought that was 30. Sorry.
However, this is invalid because while 24 only has one way of being solved, 20 has two ways of being solved. Oh wait, hold up. I might not be correct here.
80 minus 60 and what else?
Hold up.
Wait, 80 minus.
Sometimes I have like little brain sparks where I try and do addition,
And
but
24 minus 4.
but then
You're right.
Yeah, so
You're
there's
right.
80 minus
80
60, which is 20. And then there's also, oh yeah, 24. Yeah, 20 valid because there's 80 minus 60, but then also 24 minus 4. That's what I meant to say. Sorry, I'm holding everyone up. Sorry. It's 80 minus 4 minus 4.
You're excused. So thinking slowly, having these what you called addition brain farts, is that a correct quote, Nathan? Like, is that really a quote?
Yeah. At this point, it basically is. At this point, it basically is. Okay.
Totally okay to be slow and to be verbal, and I mean that just makes it entertaining for everybody. So I love it. Good. So the idea is that 20 and right, it's 24 minus 4 and 80 minus 60. Okay.
Mm-hmm.
Okay. Another 17 seconds of silence. And then I'm going to go to Oscar after those 17 seconds. Oscar, if you're still there at the bottom of that window that we see, then it'll be your turn after 17 seconds to give us a thumbs up or a thumbs down. As Angie says, as Avocado Cream says, there does seem to be a pattern here of no.
Is 15 valid? Because
okay, so it's going to be Oscar's turn after 14 more seconds of silence.
I don't think so, personally.
Okay, Oscar. Any thoughts?
I don't think so because the 5 can't be expressed using multiplication or subtraction.
Are you sure?
Right.
Because like
8 minus 3
wait, there's
is
the 8.
yeah, 8 minus 3.
Oh yeah. 8 minus 3. Yeah.
But 15 is also 3 times 5 and 40.
And 40 minus 25.
Oof. Let's hope that there's at least one yes.
Okay. Yeah, that looks like it's also a no. Okay, so that's that. Okay, I'm going to I'll do one more. Okay, here we go. This time you only get 12 seconds, and it's going to end with let's end with Solly. If you want to give us your verdict, there's got to be one of these that's a yes.
Hopefully.
Mhm.
Oh my gosh.
Okay, Solly, what do you think? Thumbs up, thumbs down?
I think this is a symbiotic set because that seems like something you would do, make all the other ones no and the last one yes.
I love it. It's called psychological mathematical problem solving. Yeah.
And also I can't seem to find anything wrong with it. If any of you guys
Oh, wait. I think I found something. Wait, 17 minus 10 and 28 minus 1? 21?
No, this one's a no.
It's a no because problems with 7. 17 minus 10 and 28 minus 21.
Oh no.
Right.
On the last one.
And this is just so sad because it like Solly's whole idea here is the art of psychological problem solving. What would the problem solver, what ideas would they have for what pattern? No, 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 no. And then finally a yes. Oh, Solly, it's sad. Okay. Maybe we should push it one more. Maybe your pattern is correct and we just need to go one more.
Okay.
This will be the last one.
Last.
Yeah, this is guaranteed to be the last one.
Ooh.
And then we're going to go and you guys are going to solve your own puzzles.
I think this is right.
Okay, so 10.3 seconds.
10.3,
And then I'm going to go to Seth.
Yeah.
Okay, what do you think, Seth? Thumbs up, thumbs down.
I didn't see. I might be wrong about this, but I didn't see a way that 18 was valid.
24 minus. No, you're right.
Yeah, I don't think 18 works.
Come
Okay.
on.
Why?
I don't see anything that works for 18.
Right.
Come on.
On the last one too.
And the last one. So we just, like, that was just terrible.
Like, wow.
Okay.
Okay, so we're gonna get to them.
I had hopes that you would do like, oh, you were planning it out, and so maybe you would do at least one right one, but nope. Unless you have some secret ones here on the slide that are actually correct.
So you can find all of these just by searching for Lichen Puzzles and MathPickle. Just Google it and you'll find all of these puzzle sheets and the video and everything.
Okay, so we did no.
And here's an example of some of these, and you guys can try which of these are symbiotic sets. And I'm telling you right now that 3 of them are and 3 of them aren't for each of these sides. So this is on page 32. 33 is the same, and then 34 and 35 are the same. Here you have to find the missing number. And lastly, you can go here and get rid of one of these numbers to make them symbiotic sets. So those are the ones that I think you should start on. You might want to save this presentation just in case there's some questionable activity, but I think that we've dealt with that. I think, fingers crossed, that that's been dealt with. So,
Oh, look, Taco Cat is finally back.
oh, hello, Taco
Hi, Taco Cat. Can you unmute now?
Yay!
Oh, great. Let's celebrate with Taco Cat.
Yay.
Taco Cat,
yay.
you have earned the right.
Taco Cat.
Yeah, Taco Cat, you have earned the right to leave off your microphone for the rest of the next 12 minutes.
Yeah. Yeah, good job.
Congratulations.
Yeah.
Congratulations. You can have, well, I don't have any more juice, but you could have the rest of my imaginary juice.
Okay. Okay, so you guys
Wait,
can.
Taco Cat, do you have the slide considering that you just joined? So the chat might be reset.
Oh, thank you very much.
Yeah.
Do you want to fix that, Seth? Can you just copy and paste again?
Chat's disabled for the participants.
Oh, you are right. Right, here it goes. Seth, thank you very much for pointing that out. That's perfect. Okay. If you stay with me on this main page, I'm going to experiment with these because I've forgotten these, and you can annotate with me. I'm going to be on page 34, but the same set of puzzles is on page 35. So if you want to just be separate from me, you can do it. Yeah.
I believe you're on 33, 34, 33.
Yeah, people are. I'm on 34.
I found you.
Yeah.
Gordon Nathan has his hand
There are
raised.
2 copies of the same thing.
Nathan, yeah, go ahead.
So you know what's funny? So all the possible symbiotic set that we've tried to do, like even like all the ones like from the ones from the video, like the ones that we're trying to do from like our own that we were trying to do to fix to make the video possible, like you know, like how we were trying to like find a symbiotic set of 5 numbers with starts with a 1 and ended with 12. And you know what's funny? The only symbiotic set in this entire presentation that we found to be correct was the one I made with the 1, 3, 4, 8, and 12. That's so funny.
Oh, and maybe this is going to continue. So maybe for the rest of this session, maybe you are going to be the only person creating symbiotic sets.
You never know.
Okay. Okay.
Nathan out.
What do you think here? What would be a good number here? So you're welcome to branch out and experiment on different pages. If you are staying on page 34, that's where I see most people are in 34 or 35. Yeah, you're an anonymous Kiwi. Thank you.
Apparently, I don't know what I am. That's fine.
Okay, so these numbers are in order. I'll tell you that. So the smallest that this number can be is a 20. Maybe that works, maybe it doesn't. Let me just make it bigger here. There we go.
It's too big.
Maybe bigger.
I don't think it's a 20.
Why?
I mean, it could be.
What
I mean,
about
it's 2
21?
times 10. Isn't that 2 times 10?
I found a solution for the first one here. I think it's 23 because that solves for 19 and 4.
4, so 23. So how many people like Seth's idea? Now, yeah. Can I have a thumbs up for this looks good? So the idea here, Seth,
Then
is
how
to
can you
solve.
make the 23?
Good point. Okay, 23 does not work. I'm sorry.
Prime?
Seth, you never have to say you're sorry. This
Yeah,
is
23
totally
is
awesome
fine.
to just throw out ideas, right or wrong.
23
it's totally
is a
awesome.
prime, which means there's no 1, which means, yeah. No.
You need a solution to get 19, and was there a solution for 4? I did not see a solution for 4. Might be wrong.
2 times 2?
Wait, we can do
You
squares?
have to have
though?
distinct. No, you have to have distinct numbers. Okay,
Ah.
so you can't use the same number twice.
Okay.
So 2 times 2 is equal to 4 does not count.
Mm-hmm.
So we need to find a
13
solution that
minus
works for 4
16.
and 19.
16 minus 12 will give us 4. Yeah, I don't think there's a way of getting it. But if you go back to 20, then 20 minus 16 would equal 4.
Ah, yeah. So yeah, I'm happy with 20 if you guys are.
Wait, how do you get 19 though? Wait.
There's no 1. I believe 19 is.
Oh. Okay, so I'm wrong. Yeah, that doesn't work.
So you need 19 plus any one of these numbers here.
Then
If you try to do did you try? Actually, wait, never mind. 21 wouldn't work. That's just. 3. Could 26 work? I think. Wait. 26 work? I don't think it. I think I'm wrong, but it does solve the problem of 19. Actually, wait.
Doesn't solve the problem of 4.
You're right.
Maybe this is impossible.
It's been possible because
Because 23, you can't solve
20
both 4 and 7, right? By the
yeah.
new number.
I thought the impossible was yesterday's puzzle.
This one's supposed to be possible. All of these are supposed to be possible.
They are? Okay.
Yeah, they are.
I think I know what the second to bottom one is.
Go ahead, Oscar.
I think the second to bottom one, the one with all those odd numbers, has to be a 25. Because if it wasn't even, it would have a bunch of that.
If it was an
I think
even,
it's 25. Because I noticed that all of those numbers are odd. Or maybe, actually, I think it can't be odd because if it was odd, then and it's got to be a 24 or a 26 because if it was odd, then nothing could be made except for things that can be made using multiplication. And not all of the numbers can be like that. So it's either 24 or 26.
okay. Yeah, I think you're right. Yeah. So that is our day today. So that is Puzzle Time, April 28th. So thank you guys very much for this week, and I will see you, most of you, again on Monday.
Bye, guys.
There's your answer.
You should just put the things that the square says in, the triangles, the round square, and the.
Are you sure?
So we're going to do this for 2 minutes, Solly. You can try to solve it in 2 minutes with the other people's help, and then we're going to go on to other stuff.
I press undo if you want.
There you go.
I drew this.
And then also you should add in the second one on top. I think you've done it. Okay, yeah.
I drew this.
So the assumption that you've made is that second clue is at the top.
Well, if it's not at the top, then the square would.
Then the square is a triangle. You're right. So that has to be like that. Got it.
And you do not necessarily know where the second.
Oh no, there's a
where
problem.
the third clue goes.
Yeah. I think you've made an error.
Yeah,
I think you've made an assumption that you didn't state, Solly, for that third clue. Okay, that's where you are now. Before you.
I think it might be this.
And wait. The top right, you don't know that is a square.
Yes, we do.
You should just get rid of the top.
Yes, we do.
Wait. Yeah, we do. We know the top.
Oh, you do? No, it's a square.
But the top left one, we're not.
Oh, okay. You do know that's pink square,
You're
right?
not completely sure about the top left one. That one, you can't say.
I'm gonna go with it and see what happens.
It remains a mystery.
So now you are assuming that the third clue is as far left as possible, Solly. That was your assumption.
This is what we end up with.
And does that work?
Yeah, that works.
Yay!
Okay, and I also have some updates on the banyan tree.
Okay, let's do the banyan tree for, if no one else disagrees, for 2 minutes, and then we'll, then it'll be adult time, if that's okay with you kids.
Okay. Got up to 46. Not sure where to place 47.
And just let me make sure, Katie and Michael have not seen this before, Solly.
Okay, so basically this puzzle is, imagine you're sucking water up through the roots, and you want your roots to expand as far as you can, but two of the previous number, and you want to stay like up here if possible, and not go straight down like with my skyscraper theory here.
Oh
So-
my.
So
Whoa.
each number that you're adding, it has to be as high as possible for the best tree in the forest. So
I've
if
gotten to
everyone's the same
47.
up to 8, if everybody's the same up to 8, and then some people have 9 on the 5th level, and some people have 9 on the 6th level, then only those on the 5th level are going to go through to the next level of the competition.
I think I won the competition by getting 19, but now I've got 46. Where do you
Where
think
is this puzzle online?
Banyan tree, MathPickle.
Okay.
So where do you think I should put 47? I could put it here. Over here.
I think that you
I
should.
could also put it over here.
So
I have
two
an idea.
numbers above the number that you're adding must add to that number. So 47 could go underneath the 46 because 1 plus 46 is equal to 47.
What number are you trying to? Do you have a
47.
goal for like a goal that you're trying to reach, like a number goal, or are you just trying to see how far you can go?
See how far I can go.
No, that's not okay. So Seth, I forgot that you didn't know the rules for this either. You're at every number that you add, every number you add, you must try to add it as high as possible. So if your tree has got 1, 2, 3,
I know how it works, but I was just wondering
okay.
because you could just put a bunch of powers of I'm not sure if you want. Well, this one kind of skipping ahead, but you could put a bunch of powers of 2 coming out from the powers of 2.
Yeah, that's what I've done.
you have.
22, 44.
1, 2, 4, 8, 16, 32. But you
Yeah.
can also put a 64 and 128, 256, and so on.
Sure. So you have to add numbers consecutively, Seth. So yeah, I have no doubt that 64 is probably going to be added onto the 32 node at some point in the future. I have no doubt that that's probably going to be the best place for it.
56 is probably going here. But where should I put 47? Because I can't find any place to put it higher than here.
47.
So 47, you think, has to go the next level down.
Yeah.
Okay.
But you're trying to
I
find a
wish we
place
did
to.
one of these for math. It would be interesting if we did one of these for math class.
Does anyone here like the puzzle Ken?
I know what it is. I'm not sure how to do it.
I can introduce Ken next week. That's, I think, better than Ken Seth. If you like those, is that a particular favorite of yours?
I guess I used to do them in the New York Times Magazine. They have it, and also in the New York Times itself. They have Kens in the paper.
Yeah, I've seen Yeah, there's never I should probably get rid of my technical difficulties.
Okay. I'm going to say goodbye to you kids now, and then us adults are going to talk for a while. And that was fun, and I will see you guys next week.
Yeah.
Bye.
Bye. See you next week.
Bye-bye.